Oh, yeah. There we go. And just a hair. Just a bit more. Cool. We had started graphing sine and cosine, right? Had we gotten to cotangent? I mean, tangent and cotangent yet? So and we graph cosine using key points.
I'll use this afternoon.
Did I not have you all sign in last week?
No, you did. You did have a sign in last week.
Just get it and move. As long as I remember what day of the week it is. Yep. If you're online, I need to go in there and look at that. Oh, I created a new channel for this class. So towards the end of class, I'll pull it up and we'll see what we can do with that. Let me see. And evidently, they came in, there was a communication issue with the Epson projector and the camera. And they fixed that evidently, which is why we were having issues with that. And Isla or Tyler, can y'all talk to me? Can you hear me? Let me put it that way.
I can
Yes,
hear
sir,
you.
I can hear you.
So the speakers in here are not working. So talk to me again.
Can you hear me?
Now I can hear you, but you're supposed to come through the speakers in the classroom and you're not coming through the audio on the
Just let me know. I can try talking again.
okay. Try this way. All right, try talking to me again.
All right, I'm talking. Can you hear me?
Oh, okay.
It's good.
Yes, you're now a disembodied voice.
Okay, cool.
And does my voice pick up okay?
Yes, sir, it does.
So, your name's in chat. Tyler, your code, I'm gonna send it to the person who's in charge and they're gonna see what's wrong with that code for my app. And if you have a temporary code and have not used it, please use it, get in there. And if you're past the expiration date, they told me that the red shelf is working. So everybody in here either has a temporary code or they're in.
What's going on, Stefan?
he has it back there.
Oh.
You could bring it back up here.
What are we on?
Where's 16.
Later in the day, we'll post the lectures on YouTube, sir.
I've been doing it,
Uh-huh.
and
His
I
message?
created a new channel for this class.
Okay,
So I haven't posted what the channel is yet, so. The end of the class. That's what I'm gonna be looking at.
Okay.
Those in Zoom, please be sure and put your name in chat. So you can count it present. The first exam is next Thursday. Everything, well, if we get to the end of a section, then that's the last section that will be on this upcoming exam. From 6.1 to wherever we wind up today. Oh. Here's the deal about the homeworks and the review and the exams. The homework generally is more difficult than the review, and the review is on the whole more difficult than the exam. So if you don't have too much trouble with the homework and you don't have too much trouble with the review, or you understand the review, you shouldn't have any issues with the exam. Most people who have completed the homeworks and are up to speed with the review didn't have too many problems with the review, generally make a B or better on the exam. Most of the problems on the test are worth 10 points. So if you understand the concept or the procedure you're supposed to use, then minor errors in arithmetic will only lose you 2 or 3 points. So, but if there are issues with the process, that's where you lose points. So understanding how to do it, like how to do the graphing, that's if there are just some minor mistakes in arithmetic, or you set the period wrong or something like that, then that's just a few points. That's not the whole problem. So I'm not one of these professors who say it's either right or wrong. So, questions? Oh, by next Tuesday, I expect you to have worked the review at some level, either completed every problem or at least worked every problem to some degree. And so we'll discuss any issues or any questions you might have at that time next Tuesday. How I do the review is I answer questions from you. So if you have an issue with this type of problem, I want to know about it so we can address it. I guarantee if one person has an issue, then at least one other person has the same issue. So.
A C4, sir.
Hmm?
A C4?
Yeah, I saw an ad for it, a billboard, a billboard, so, and they had 0. Yeah, so, yeah. This is the one I usually drink.
Another. Ooh, sir.
Or I had one of these
Oh,
today.
it's Starburst flavor too. Is that what?
Yeah, this one's cherry, but I haven't really, I drink them so fast, I don't taste it.
Yeah.
So,
Does it run up your heart rate, sir? Does it make you feel a little,
no,
no?
it keeps me from, sleeping on my keyboard.
Oh, okay.
Okay. So. All right. And by this evening sometime, I will have posted the new channel for the YouTube, and everything will be in there, including today's. I've already, this is the only class I haven't totally uploaded everything yet. Because of the issues, I had to create a new channel and start reloading everything. So, and today I just finished uploading, all my other classes are up to date. So this is the only one I'm behind on. And I think I just uploaded September 2nd, right before I came. So. Use their pens. Okay. So, whoops. We're gonna graph this.
Are we doing example 6?
Huh?
Are we doing example 6?
Is this example? Oh, did we do example 6?
No, not yet?
Okay.
Yeah, no, we didn't.
That's a good call there.
Yeah, we didn't do any of that, sir.
Okay.
Oh, thank you.
Okay. So. The function is 4 times the sine. What is that? Negative pi over 4x. Well, sine of a negative is the negative of the sine of the positive, because it's an odd function. So I can pull this negative sign out, and it's easier to deal with if you pull the negative sign out. Sine of pi over 4x.
So the way you said that, can you say that one more time? Sign of a negative is the what?
The sign of a negative is the negative of the sign
Negative of the sign.
of the positive. That's because sine is an odd function. Okay. So omega in this case is pi over 4. A, absolute value of A is 4. So that's the amplitude. The period is 2 pi divided by omega. So this would be 2 pi divided by pi over 4, which is the same thing as 2 pi times 4 over pi. Dividing by a fraction is multiplying by its reciprocal, and that 4 looks like a U. Okay. And now I wrote it as a Y. Damn it. Okay. So the pi's go to 1, and 2 times 4 is 8. So the period is 8. So I make a little number line from 0 to 8. I half is 4, a half of 4 is 2, and halfway between 4 and 8 is 6. So these are gonna be my 5 key points. Okay. Sign here is 0. Sign here is 1. Sign here is 0. Sign here is -1, and sign here is back to 0. So that's how I'm going to graph it. So, all right. Now, because the amplitude is 4, now I'm going to multiply each of these numbers here by 4, because now I'm going to change my maximum value and my minimum value. But we still have to worry about this -4. So I'm going to multiply by -4 and take care of not only the stretch, but also the reflection. Because now the maximum becomes the minimum and the minimum becomes the maximum. So I'm multiplying each of these values up here. These are the y values and these are the x values. So 0 times -4 is still 0. 0 times 1 is -4. 0 times -4 is still 0. -1 times -4 is a +4. And 0 times -4 is still 0. So the ordered pairs we're going to be graphing are, are going to be 0, 0, 2, -4, 4, 0, 6, 4, and 8, 0. So 1, 2, 4. 1, 2. And here we have 1, 2, 6, 7, 8. And I'm going to come out here 10, and I'm going to come down here to -2. So when x is 0, y is 0. When x is 2, y is -4 here. When x is 4, y is 0. When x is 6, y is 4. And then when it's 8, it's going to be 0. And then at 10 again, it's going to be at -6. I mean, -4. And same thing is going to happen at -2. We're going to come down. No, we're going to go up here to +4. So my function, the graph, is like this. Finding those key points, finding the period, and then finding out where those key points lie. Makes this graphing easy peasy. Questions? Does everyone understand how I got the period as Z? Does everyone understand how I got these y values that went with these numbers? The key points we're talking about are, if you look on the unit circle, so we have the cardinal points of the unit circle. So we have pi over 2, we have pi, we have 3 pi over 2, and we have 2 pi. And we start with 0. At 0, this point is 1, 0. This point here is 0, 1. This point over here is -1, 0. And this point down here is 0, -1. So at 0, the y value, we're just looking at the y value of these points, because that's the sign. And so when we have pi over 2, the sign is 1. And when we have pi,
Sign 0.
the sign is 0. And when we have 3 pi over 2, or 3/2 pi, we have the y value is -1. And then we come back to full circle at 2 pi. So that means sign is going to be 0 again. So these are the y values here. And the x values are the angle. Well, this is based on the period of 2 pi. But now our period has changed from 0 to 8. And so these numbers here, these 5 numbers here, 0, 2 pi, pi, half a pi, pi, 3/4 pi, 3/2 pi, and 2 pi correspond with these x values here because of what happens with this. So what happened was I did the 2 pi, which is just above 6, got pulled out further. So all these x values got stretched out away from the y-axis. So now 2 corresponds with 2 pi, half a pi. So this 1/2 got moved over to here. So the y value is 1. So we have the point now 2, 1. And the 4 here corresponds with pi. So that's going to be for the 4, 0. And same thing here. So the 6 is going to be with the -1, and the 8 is going the full circle. So that's going to be 0 again. And this was still at 0, 0. The only point that doesn't change is the 0, 0. But now because of the amplitude, we're changing our high and low. So it's no longer 1 and -1. Now it's going to be 4 and -4. But because we're multiplying by a negative, see, we're gonna switch this maximum to a minimum by multiplying by -4. And we're going to switch this minimum to a maximum by multiplying it by -4. So -1 times -4 gave us the 4. The zeros stay 0. Did that help? And then I just graphed these 5 points and I extended it. Since it's periodic, that means this point here, if I go 2 units this way, it's going to be the sine is an odd function, which means it's symmetric with respect to 0. So this point, if I change both signs, it comes up to here. This one, if I change both signs, will come down here at -6, -4. And the zeros will stay at 0. It's just the x values will be negative. And so it just continues. Every 2 units, we hit a minimum or a maximum. So at 12, we're going to have a maximum. At 14, we're going to have a minimum. At 16, we're going to have another maximum. and on and on and on and on. Okay? And going in the negative direction as well. Yeah.
Step on.
I'm gonna erase this and see how they do it. They should get the same graph. And they should get the same ordered pairs, but I think what they're gonna do is, they're gonna find that they're gonna deal with the reflection, this negative aspect of 4, separate from 4. So they're gonna look at multiplying by -1 and then looking at what happens with the 4. All right, so yeah, they did the same thing I did. And then omega was pi over 4. Did I use pi? Yeah, I used pi over 4. And alpha is -4. A is -4, so the amplitude is 4, and the period is 8. What?
Oh, I see, because they divided,
You're dividing by omega.
Yeah.
Which means you're multiplying by the reciprocal. And I need to change that, because that freaks me out.
you can't bring down the projectors thing.
And they'll
Then,
plus
like, you
that.
can't write there, you know?
Yeah, I know. Okay, so the cycle begins at 0 and ends at 8. And so we divide the interval 0 to 8 into 4 equal positions. So what they do is, I like to do it on a number line because it's easy for me to see it. And but so each interval in that period is 2 units long. So 0 plus 2, and then 2 plus 2, and then 4 plus 2, and then 6 plus 2. So you get all the intervals, the 4 intervals. And so, yeah, they found the 5 key points, the X values of the 5 key points, which is what I did with the number line.
Right.
Okay, so they're doing the same thing I did, but I did mine on a number. It works out the same. All right. So sine at 0 is 0. I forgot to put 0 here. Oh, there we go. And then sine when x is 2 is the same as this at pi halves. Right, because that's the reference angle for x equal to 2, because we changed the period. So now the 2, whatever happens here is what this is. And they get -4, because the sine of pi over 2 is 1, and 1 times -4 is -4. So they're basically doing it the same way I did. All right, sine of pi. At pi, sine is 0, so this is 0. At 3/4, at 3/2 pi, sine is -1, so -1 times -4 is 4. And then at 2 pi, you're back to 0. And so there are our ordered pairs. 0, 0, 2, -4, 4, 0, 6, 4, and 8, 0, same points I had gotten. And I got them the same way they did. I just represented it differently. Because I looked at the 5 key points from 0 to 2 pi. and then change the X values to fit the new period, and then multiply the Y values by the amplitude or by the coefficient, which was -4. And so they graph those points and sketch the graph in, and then they continued it out, or actually, what did they do? They went out. They went out an extra period this way and another period back this way. So they did a whole period negative and a whole another period positive. 8 + 8 is 16. So this is a complete period, another period. And I stopped here. So was it here I stopped, or did I come down to here? I think I
Down to
stopped
10.
at, oh, I went to 10. Okay, so that would have been this point, yeah, which is what they have here.
I thought you meant 10.6.
No, it's 10 -4 because the minimum value is -4.
Gotcha.
Okay. Now, on an exam, I want you to show more than a single period. You don't need to go as far as they did, but you need to show more than a single period. Because that tells me you understand what's happening. Now with cosine, we're going to do the same thing. That's cosine -4 cosine pi x -2. All right, so they threw in a vertical shift. The -2 here means I'm going to shift the entire graph down 2 units. So I want to find out what happens with those key values, and then I'm going to subtract 2 from each of the Y values. So the key values are 0, 1, because we're talking cosine now. 0, 1, and pi/2, 0. Because if I erased it already. I need to learn to leave this up. So our cardinal points 1, 0, 0, 1, -1, 0, and 0, -1. Now we're looking at the Y values, the X values of each of these points. So when Y is 0, when the angle is 0, cosine is 1. When the angle is pi/2, cosine is 0. And when the angle is pi, cosine is -1. When the angle is 3/2 pi, the cosine is -1. And then when we go full circle, we're back to 0 again. Omega in this case, omega is pi. So that means the period is 2, since the period is 2 pi over omega, then this is going to be 2 pi divided by pi. So those go to 1, and that just leaves us 2. So now my goes from 0 to 2.
For what?
For the period, what?
That was a formula, right? T equals
2 pi over omega.
what? T. Okay, so T
That's the
equals
period. That's the formula for the period.
2 pi over omega.
For some bizarre reason, whoever came up with this and everybody agreed, we're gonna use T to represent period.
And omega equals pi.
Omega, in this case, because X is being multiplied by pi, omega is pi.
From that equation, y equals A sine times omega x.
Okay.
Theta.
So I need to divide this into 4 regions. Halfway is 1, and then the bottom half is 1/2, and the upper half, the middle of the upper half is, 1 1/2 or 3/2. I prefer the
3/2.
improper fractions as opposed to the improper. As opposed to the mixed number. But if you write 1/2, I'm not gonna, that's fine. I did,
Makes more sense.
Yeah. oh. So now the X values of these are gonna change. So now this is still 0, 1, but this is now 1/2 0. And this is 1 negative 1. And this is 3/2 0. And this is 2 negative 1. 2 1. I was looking here. 2 0. Okay. Basically, I took pi away. Because I'm dividing the pi out. So if it has a pi in it, it's going to disappear. And we're always multiplying by 1. Okay. Now, since we're multiplying by negative 1/4, we're going to multiply each of the y values by negative 4. Wait a minute, I got off here, didn't I? Oh no, this is back to 1.
And
Sorry.
isn't the 3/2, isn't that a negative 1? You have 3/2 over 0, or you have 3/2 and 0, isn't it negative
1.
1? Did you get it wrong?
Negative 1. Okay.
Okay.
And this is going to be 0, and this is going to be 1.
Okay.
Good catch, Stefan.
Okay, because it goes 1 0 negative 1 0 1. Okay, so it bounces back and forth between negative 1 and 1.
Go for the ride, baby.
And now I'm going to multiply each y value by negative 4. So we have 0, negative 4. So negative, because I'm multiplying the cosine by negative 4. That's the y value. The y value I'm going to multiply by negative 4. So now it's negative 4 here. I'm still going to be at 0 here.
We're only going to multiply the y's.
Only the y's. We already changed the x's to fit
Yeah.
the new period.
Yeah.
Now we're going to make the y's fit the new maximum and minimum by multiplying by negative 4. And so this becomes 1 4. And this stays 3/2 0. And this becomes 2 negative 4. So graphing this, this is here.
So that's what they're looking for at the end of the day. It's that ordered pair.
Yeah, once you get these, the graphing part is easy.
Right. That's the
It's
answer.
getting these.
Yeah.
Any questions here on how I got those?
I don't know.
Including you there in that camera.
Oh, no, sir.
All 2 of you.
There's only 2 people there?
Yeah, there had been 4, but 2 of them disappeared.
So a lot of people have to. Huh.
Well, people have issues with Zoom. Sometimes their PC drops it, or they're on their phone and they lose Wi-Fi connection. Those things happen.
Gotcha.
So where am I? Oh, graphic. So one period is from 0 to 2, and so that's going to be 1 year and 1/2 here and 3 halves here. And then we come over here to 3 and then out here to 4 and back down here to -1. So I'd really just go this far. And this would be 5 halves. So this is probably as far as I would go with it. If you want to go further, that's great, more power to you. Okay, so 0, -4. So 1, 2, 4 down here. And 1, 2, 3, 4 up here. So, and so we have 0, -4. And then we have 1/2 0. And then at 1, it bounces up all the way to 4 up here. Fix this. And then at 3 halves, it's back to 0. And then at 2, it's back down to -4. And that means at 5 halves, it's going to be back at 0. And at 3, it's going to be at the maximum. And then, well, because cosine is an even function, when I go this way, it's just going to repeat the same points in the same order, but going this way. Because I'm just changing the sign on my x values and keeping the y the same. So that's going to be a -1/2 0. And this one's going to be -1
4.
4. Oh, yeah. So the graph is going to look like this. Get your arrows at the end because it doesn't stop. That's one of the hardest things to get 14-year-olds to do when they're graphing a line. They say this is a line. No, it isn't. Without the arrows,
It's
it's a line segment.
if you just have, it's a pointed, it ends.
I started taking off 5 points
It's important.
after a while because I wanted them to put those arrows.
Wow, sir. You rarely take off points. That's messed up.
But no, it's
Well,
important. That's important.
Oh, no.
Notation is important because I need to, that's how we communicate in mathematics is through the notations. So if I don't put arrows in, then how do I know it doesn't stop?
So you're gonna draw us like that too?
No.
You should already. Yeah. You should already-
No, there are professors who will know. I'm not. If this was like an upper course, like well, even beyond calculus. Calculus 1, I wouldn't be that picky about it. But in Cal 2 and possibly other upper division ones, I would be picky about it.
Sir, I have a question about the pi x. So omega, well, so is x omega?
No, that's omega.
Okay,
Because the general form here we're talking about
okay,
is a times the cosine of omega x
Bless you.
plus b.
okay.
Oh, I wasn't done yet because I forgot about the
Oh my
-2.
Gosh, sir. Come on.
So that wasn't the graph. Because now we have to do the -2, and it's because it happens after the function, it's in the sign. So I'm going to subtract 2 from each of these y values. So this was -4 times the cosine. And now we're going to have -4 times the cosine -2.
That's what I was kind of getting. I was like, where does the
Okay.
2 come in?
Yeah, well, because I forgot it. So we subtract 2 from -4, that gives us a -6. Subtract 2 from 0, that gives us a -2. Subtract 2 from 4, that gives us a 2. Subtract 2 from 0, and that gives us a -2. And then subtracting 2 here gives us a -6 again. So now our new minimums are -6 and our maximums are 2. So it's like I'm taking this line here
Scrunch.
and I'm moving it up 2 units. So I'm bringing it up to here. So now this is -6 down here, and this is +2 up here. And instead of this being 0, this is now -2. The graph is going to look exactly the same. It's just been moved down.
But that formula period equals 2 pi over omega. That's a constant, right? That is a formula.
Yeah.
Okay. Yeah. No.
So whatever x is being multiplied, that's our omega.
Okay. Yeah.
And then this is the amplitude.
What about the 1/2 x over here? The 1/2 x, shouldn't that be -2?
This one
On the graph.
on the graph, yeah, it should be at -2. Well, yeah, all I did was shift my x-axis up to here. So instead of this being -4, now this is -6. Instead of the x-axis being 0, it's now -2. So all these points here are at -2 in the y. Because now my x-axis is up here. Oh, it's the same color. Just in black. So now this is my new x-axis. Because all these points got moved down 2 units. So now this isn't 0. This is -2. So instead of erasing it, and redoing it, I just shifted my x-axis. I got lazy. So this is -1 up here and -1/2 here. Actually here. That's the -2.
And this is all using the key points, correct?
Yeah.
Those, what do you call them? Cardinal points?
Cardinal points, because it's like the cardinal points on a map is north, east, west, and south.
Okay.
Questions?
And this was cosine.
Well, it would work the same with with sine or cosine. Okay. It's just your key points are going to be different.
Yeah, it's X or Y that you're using.
So comparing it with that, omega is a is -4 and omega is pi. And so that means the period is you're gonna divide 2 pi by pi, which gives us 2. The amplitude is 4. So it goes, and they divvy up their the cycle is 2, so they divide 2 by 4, which is 1/2. So each section is 1/2 units long. And they'll get these same numbers, but they'll do it doing the arithmetic, adding 1/2 to get those and get the same.
And in that way, you're gonna always divide by 4. The way they show,
Oh,
right?
yeah, doing it their way, you're dividing the period by 4 in this case.
Okay.
But yeah, you're always dividing by 4. So when the period was 8, we divided 8 by 4 and got 2. And so each period was each interval was 2 units long.
Got it.
Sir, how do you find the Y value?
These y values? Okay, to start out with, we look at from the unit circle, the cosine is the x values. And that's how I got these. And what happens to the y values, you multiply by the a. So we multiply each of these y values by a. And a is -4. So I multiplied this by negative. Well, first thing I did was I changed my x values to fit the new period.
You divide by pi.
And then I multiply each of the y values by -4. So that's how I got the -4s. I mean, the -4 and the +4 by multiplying by -4. 0 is going to stay 0. And that's going to give you +4. 0 stays 0. And that became a -4.
And our B is -2.
Because we have we have a b value, and the b value is -2. If we're subtracting, then the b value is negative. And so I add -2 to -4 gives me -6. Add -2 to 0 gives me -2. Add -2 to 4 gives me 2. Add -2 to 0 gives me -2. And add -2 to -4 gives me -6. Or I subtract 2 in each case. Either way, you get to the same place. Is that helping? Yeah, I kind of wrote it over what we were doing. And this was changing the y values. The x values get changed pretty quickly and pretty easily. The trick is the y value. Well, it disappeared from here, but it stayed up there. Let's see. Yeah. PowerPoint froze on.
Just for a second.
No. It's
It crashed.
got.
Oh, that's fine.
It's like.
like-
And then go back in.
Very well.
It's fading like when Thanos.
Once in a while.
Look at it. It's just-
Restart. There we go.
Oh my God.
Maybe. Did it faded?
Yeah, it's got Thanos.
So this has happened in every classroom so far.
How long has it been lasting?
Not every day.
You taking a 5-minute break?
It's not PowerPoint. I want it.
What happens when?
The breaks are before and after.
Are they?
Here we.
I have some faster breaks.
What?
Like my 3-hour lab break. My 3-hour government class has a break.
Yeah, if you have a class that's 2 hours or longer, you're supposed to have a break in the middle.
3-hour government.
But we don't take the break, we just leave 15 minutes early. Just kind of cool. Oh, shh.
Everybody does it.
My teacher's been doing that, she's great.
Anybody remember what the slide number was?
The sign?
Slide.
The slide number.
Oh, 130. 130s, maybe?
There we go. Yeah, it doesn't take long. It's just a pain in the area. Okay, so. So we found those intervals, and the intervals are, yeah, so we find the 5 intervals. And that's this set of points here. Actually, it was this set of points here that they show here. Oh, here they're showing what the new X values are, which is what I have here. And then they multiply the Y values of the cardinal points by -4. And then we subtract 2 from each. Well, they were here. Let's see their graphs. So I basically did what they did. I just fixed my mistake by doing what they did. Okay. So this is the graph I had graphed originally, and then we just they shipped it down 2 units to get this graph, which is the graph I wound up with by shifting my x-axis up 2 units to fit this. And that looks like what they just did. All they did was take the x-axis and move it up 2 units for it to show a downward shift.
Right.
And so these are the key points that you wind up with. What used to be your x-intercepts are no longer your x-intercepts
Because of your shift
because you shifted your x-axis.
vertically.
Right. The domain is still going to be our real numbers. Our range changed because we did a vertical shift and we did a change in amplitude. The amplitude is no longer 1. So the lowest y value is -6, the highest y value is 1. So my range is the closed interval -6 to 2. I'm sorry, it was a 2, not a 1. So this is my range. Bounces up and down between. So we can either write it as in set builder notation, or we can write it in as an interval notation. In MyLab, they will ask you specifically to write it one way or the other, or they'll go through both of them. On the test, if I ask you this, I don't care which method you use. You can even talk about it verbally, saying that the y values range from -6 to +2, including those points. Endpoints.
Yes.
Here we have a sinusoidal function. And we want to write an equation for it. It goes through 0, 0. That means I can use sine,
Yes.
because sine of 0, 0. So I can start out, I can say that it's going to be a sine omega x. So so sine goes from 0, 0 to pi halves 1, right? Well, my period here is 4. I can figure out what omega is by the period. So that meant 2 pi divided by omega is the period, and the period here is 4.
Yes. Well, omega's 4, right?
No, omega is not 4.
Omega's omega.
Oh, omega.
Omega ends up being half pi.
Period is 2 pi over
I don't
omega.
know.
2 pi over omega.
If I can one of the
It's 4. Yeah, it comes out to 4 because you just said it was 2 pi over 2, right? Because omega is pi over 2.
yeah.
Yeah, so then it comes out.
In
to
this
4.
case, omega winds up being pi over 2.
If you cancel out the pi's, you're left with 2 over. Yeah.
Well, to solve this, I use a trick because I know about proportions.
Yeah.
The numerator and denominator, the numerator of one fraction can be switched with the denominator of the other fraction. So I can rewrite this as 2 pi over 4 equals omega over 1. That's how I do it in my head. However, you can multiply both sides by omega and you have 2 pi equals 4 omega, and then divide by 4, so you wind up with omega equals 2 pi over 4, which is pi over 2. So omega is pi over 2. I over-explained it. So now we have y equals a sine pi over 2x. That fits the period. Now we want to fit the amplitude. What is the amplitude here?
2.
2. The highest it goes is 2, the lowest it goes is -2. So its amplitude is 2. Amplitude is always positive. Now, the question is, am I multiplying by 2 or -2?
Positive.
Right, because at here, it goes to, what is that? 1, 1, 2. So what do I multiply 1 by to get 2? 2. So A is 2. So my equation here is 2 sine pi over 2x. The main reason we want to put the argument of the trig function inside parentheses is because if you're adding and subtracting something, you want it to be separate from that. So even if omega is 1 and you just have sine of x, it's usually a good idea to put parentheses around it to tell me if I'm adding or subtracting something there that it doesn't go with the x. Okay. And it has characteristics of a sine function. So period is 4 and A is 2. The period is 4. So from the period, we determined that omega is pi over 2. And they did it the same way I did it, only they didn't do it as messy as I did. They showed what you do to find, they set up to find omega. They didn't go through the manipulation to find out what omega is, or the algebra.
Hey, so a second ago you said you overworked that equation, but I appreciate you doing that because I really showed me how we got to it.
Yeah. Well, and I like
I don't know.
that is not a good sign.
Oh, that was. Did you hear something else?
It was a ding.
Oh, that was my phone.
Oh, it's your phone. Okay.
Hearing things.
If the computer makes that sound, it's not a good sign. Here we have another one.
Let's do it.
All right. I always look to see what happens on the y-axis.
Can you sign?
We're going to use sine again
Yes.
because the 0.00 is on the graph, even though this is a little off. Now, our period is 8. So t equals 8, which is 2 pi over omega. So we have 8 omega. 8 omega equals 2 pi. Dividing by 8, we get omega is pi over 4. So now it's going to be a sine pi force of x.
With an amplitude of 3.
Yeah, because now here, our lowest value is at -3. Our highest value is at +3. So the amplitude, the absolute value of A is 3. So that means I'm either multiplying by 3 or -3. So at off of the unit circle, 0, sine gives you a value of 0. And at pi over 2, which is the next key point, the y value is 1. So if I multiply 1 by 3, I get 3. I get up here, I don't get down here. So what am I supposed to multiply by? -3. -3. So A is -3. So -3 sine of pi over 4, x. That's my function. Questions? I like the classes that ask questions.
Oh, okay, well then I do have a question.
Well, okay,
So the last equation, the omega was pi over 2.
right.
And the period was 4. Since on this one, the period was 8, could we have just doubled it like in our head? Well, the last one we got pi over
Did-
2.
Is this double pi over 2?
I mean, what's the opposite of double?
Half.
So it works like that though, right?
Yeah.
Okay. So we could have said that then.
It's better to work it out this way.
Yes.
Because it doesn't, like, what if this was a 10, not an 8? So this would have been a 5 here. So it would have been 10 equals 2 pi over.
To multiply 8 equals 2 pi over omega. We flipped, like you said, the proportions, we flipped, and now it's,
All I did was set it up this way, multiply both sides by omega, and then divide by 8.
okay.
But you were talking about that other thing. You said
When I
right?
talked about proportions. Then, well, eventually what we end up doing is switching the omega with the 8. That's that whole process we're doing is switching the 8 and the omega to get omega equals 2 pi over 8, which is pi over 4.
So really that when you multiply by omega, it's 8 omega over 1.
Right. So they got omega is pi over 4. Since the graph passes through the origin but is decreasing about the origin, then the sign is being reflected about the x-axis, which means we're multiplying by negative. The amplitude was 3, and since we need to multiply by a negative, a will be a -3, which is what we discovered simply by looking at what happens with the graph, where it was supposed to wind up and where it actually wound up.
Omega equals 8 at the end of the day, right?
In this case, no, omega is not 8.
Pi over 4.
Omega is pi over 4, right? 8 is the period.
Yeah, that makes sense.
Okay. And so they come up with the same function we did. These graphs haven't been giving you nightmares. Now they really kick in. Okay. We're going to look at these graphs. You might, I don't think we're going to finish this section today. So you might see something about sine and cosine functions, but I don't think I will throw one of these on the exam. If I do, it'll be an extra credit. So, oh yeah, tangent. Yeah, sine and tangent. I mean, tangent and cotangent and secant and cosecant. I don't know why this textbook has decided to say cosecant and then secant. I always, it's secant and cosecant. Because you have sine and cosine. Tangent and cotangent.
What, this is 6.4 now?
No, we're still in the same. Are we still in the same? No, yeah, we're in a different section.
6.5.
6.5, yeah, okay. Wow, all right. think we have one more section in chapter 6 to cover. Or this is the last section.
No, there's 6.6.
I don't know. I don't remember what that one covers. Okay. The graphs of tangent and cotangent look very similar. Realize, all right, if we have go back to the unit circle. See, knowing the unit circle really helps because you can use it all the time when you're talking trig functions. So I have 1, 0, and when the angle is 0, when the angle is pi over 2, I have 0, 1, and when the angle is pi, I have -1, 0, and when the angle is 3/2 pi, I have the point 0, -1. And then when I come back to 2 pi, I have the point 0, 1 again. Now, tangent is sine over cosine. Sine over cosine. So that's going to be y over x. So here I have 0 over 1. Here I have 1 over 0. Here I have 0 over -1. And here I have -1 over 0. Well, when it's over 0, it doesn't exist.
Yeah.
So what happens here, and they're not showing it here, what happens at -1/2 and what happens at +1/2, we have asymptotes.
Asymptotes.
Because as x approaches -1/2, the y values get more and more negative. And as x approaches +1/2, the y values get more and more positive. So it goes towards infinity there and goes towards -infinity here. And so on the other side, you have the exact same thing happening. So on this side, it's going towards +infinity, but on the other side of the asymptote, it's going towards -infinity.
And then cotangents flip, right?
Cotangent, yeah, it's
Isn't it just
flipped
going
and
like this?
shifted. Because now instead of not existing at pi, at the half pies, now it's not going to exist at the whole pies.
Yeah.
So cotangent can't eat a whole pie. But tangent can. So they can eat all the pumpkin pie they want. Okay.
Sir, come on.
I love pumpkin pie. I cook it. I make it from, I use raw pumpkin.
I
cook
remember
the
you were
pumpkin.
saying, so you get the
Oh, yeah.
small bright orange ones and you put them in the oven on 350 for whatever degree.
For about an hour,
Huh?
and you pull them out when they start falling away from the skin. And, yeah.
Do you
You put
share
that
them
in
with
a-
your friends?
Huh?
Do you share them with your friends?
They have the opportunity to
Ah,
have some if they want
okay.
some. Let me put it that way.
Good to know.
I always make 2 pies. Because I'll eat 1 pie. One year I ate a pie and a half because nobody was eating a pie. And you gotta have whipped cream with it. So my blood sugars go up.
So you
into that.
started doing math with the pie.
We are.
Yep.
Unit circle pie.
Okay.
Ah. No puns.
Where am I? Oh. So looking at unit circle and with pi, I mean with tangent, they were looking at the 30-degree and the 150-degree. The period for pi, I mean the period for tangent is 1 pi. Okay. Oh, it is 1 pi, but it's not, they started at negative pi over 2 and go to pi over 2. And so this is, yeah, in the first and third, and first and fourth quadrant is the basic period for tangent from here to here. And so they didn't put the 45-degree angle in there, is all. Oh, they did. They did, 45-degree angle. Okay, so at a negative 60, tangent is
5 pi over 4.
negative square root of 3. Because down here, all right, here at pi thirds, it is 1/2 square root of 3 over 2, and you divide the square root of 3 over 2 by 1/2, and you get the square root of 3. Down here, it's going to be the square root of 3 over 2 1/2, and so the tangent is going to be 1 over the square root of 3 over 2, which becomes the square root of 3 over 3. So tangent is the square root of 3 over 3 at this at pi over 6,
Oh,
and it is it's the square root of 3 at 1/3, and at pi over 4, they're the x and y are equal, so it's 1.
y over x is tangent.
Y over x is tangent.
Mhm.
And then when you go the negative direction, it's going to be, you're just changing the signs here. You're changing this because tangent is an odd function. I change the sign on these to get these down here. And then at negative 1/2 pi and positive 1/2 pi, the function does not exist. We have a horizontal, I mean a vertical asymptote at this point. And for this graph, they're just going from negative pi over 3 to pi over 3. So they're not including this entire period on this graph. The next slide shows it better.
Yep.
This year is the first year this has made sense to me.
What?
Yeah. I've always had issues with it. Because I just couldn't wrap my mind around it for some bizarre reason. So this is one period, and the periods repeat. So at every multiple of 1/2, odd multiple of 1/2 pi, you have a vertical asymptote. I think they state that later, but and then at the whole at the multiples of pi is where the zeros are. These are at the multiples of pi, it crosses the x-axis.
Sir, do we have access to these slides on the MyLab?
No, you go to files in Canvas, go to
Okay.
files, and there should be a PDF file that has all of these.
Okay,
And the PDF file has 6 slides per page. If you want it to be 1 slide per page, email me and I'll post that as well.
okay.
But not everybody wants that. I had one person in a free calculus class. She printed every single slide up. Made a book out of it. And so on one side, she took notes for the slide, for that next slide. And she was one of my better students. Well, she asked all kinds of questions. Kept me on my toes. I like that. I like classes that ask a lot of questions because they keep me on my toes. And it also shows me that people are working at understanding material. So. All right, the domain is all real numbers except for all multiples of pi over 2. The range is all real numbers, because if you look at this graph, yeah, this goes all the way to infinity, that goes all the way negative infinity, that goes all the way to positive infinity, and they keep repeating. So yeah, it's all real numbers, the range. The tangent function is odd, we already discussed that. And therefore it's symmetric with respect to the origin. And because it's symmetric with respect to the origin, all I need to do is find everything on this side, and then I just change both signs and I get this side. So if I just find everything that's in the first quadrant, I can change all the signs and I find everything in the fourth quadrant. It's periodic and its period is pi. The x-intercepts are at the multiples of pi, and the y-intercept is 0. So 0, 0 is both an x-intercept and a y-intercept. The vertical asymptotes occur at the odd multiples of pi over 2. Cotangent. Yeah, here it is.
See this? Except it crosses at,
Yeah,
it doesn't cross at the origin.
right. Because at x equal to 0, cotangent doesn't exist.
Like you said, it's outside of the pie,
Well,
outside of the circle.
yeah, and they erased it already, but
No, it's, yes, I get it.
no, this is an important concept. So now our period is still pi, but notice we start at pi over 6 and we go to 5 pi over 6. So that's here. Tangent was here for the period, for the first period, goes from fourth to first quadrants. But for cotangent, it goes from first to third. I mean, first to second, sorry. Tangent goes from fourth to first, and cotangent goes from first to second quadrants for its first period, or the primary period, and all the other ones just build off of that. So we don't go full circle for the period, we just go half a circle. And instead of being y over x, now it's x over y. And so where here we have 1, 0, for this point, 1 over 0 doesn't exist. It's undefined. And so the function does not, the cotangent doesn't exist at 0. It doesn't exist at pi, 2 pi, 3 pi, 4 pi, 6 pi, or going in the negative direction, negative pi, negative 2 pi, negative 3 pi, negative 4 pi. So that's where we have the vertical asymptotes at the integer multiples of pi. And we'll talk about that in the pi over 2 was an asymptote for tangent, but pi over 2 is an x-intercept for cotangent. So where we have an x-intercept for tangent, we have a vertical asymptote for cotangent. And where we have a vertical asymptote for tangent, we have a intercept, an x-intercept for cotangent. So the cotangent x-intercepts are the odd multiples of pi over 2. And the domain is all real numbers except for multiples of pi.
That's what I was about to say. So the domain is all real numbers except for the odd multiples.
Yes, the odd integer multiples of pi.
Yeah.
Gotta throw pi.
Okay.
Yeah, that's what it's saying here. That from negative infinity to infinity, that's where x is, but x is not equal to the integer multiples of pi. And the y values, again, are going to be all real numbers. Please notice that the general form of the tangent function looks just like the general form for sine and cosine. We have omega, we have the amplitude, and we have b. Now, realizing that we don't have a maximum value,
There's no maximums and minimums.
right? Because the range goes from negative infinity to positive infinity. So it's just either stretching it out away from the x-axis or compressing it towards the x-axis. Whatever A is doing. That's what A does. And the B value just shifts where the x-axis is. So now we're talking about 3/2 tangent x plus 1/2. Well, let's see how they do it, because I don't want to get in there and do it totally different. All right, so using the steps to show the transformations of tangent x. All right. I'm just going to look inside here, and these are just going to repeat what happens in here. So we're going to multiply each y value by 3/2. Because A is 3/2. So I'm going to multiply each of these values here by 3/2. So this -1 becomes a -3/2. This 1 becomes a positive 3/2. So it got stretched away from the x-axis, so it got elongated. And so this is just a repeat of these here. It's just been shifted of pi units to the right, and down here it's going to shift it pi units to the left. And then the next one's going to look exactly like this one. Now we're going to deal with the b value, and the b value was 1/2. Was it 1/2? Yeah, we're adding 1/2. The b value, we're changing the y value again, but instead of multiplying, we're adding. So I'm going to add 1/2 to a negative 3/2. And I'm gonna add half to 0. And I'm gonna add a half to 3/2. Okay. Please notice I didn't mention anything happening to the point 0, 0, because multiplying 0 by 0 is not gonna change this point. So all the x-intercepts didn't change. Now, since we're going to change since our b value is not 0, we're going to change where it crosses the x-axis. So a negative 3/2 plus 1/2 gives us a negative 1. 0 plus 1/2 gives us 1/2. So the y value changed to 1/2. And adding 1/2 to 3/2 gives us 2. So this had been at pi over 4, 3/2. Now it's at pi over 4, 2. So they're going to change those numbers the same way we had been doing it. Only they're not using as many points as we did. So they had negative 4. Negative pi over 4, negative 1, and then at 0, it's 0, and then at what is it? At pi over 4, it was positive 1, and so that dealt with this point here, and this point here. Multiplied each of the y values by 3/2, so that gave us a negative pi force over 4, and a negative 3/2, because 3/2 times a negative 1 is a negative 3/2, and 0 times 0 is 0, so 0, 0 remains 0, 0. And multiplying 1 by 3/2, this becomes pi over 4, 3/2. That's multiplying each of the y values by 3/2. And then we're going to add, because it was a shift up, we're adding a positive 1/2 to each of the y values. So the negative 3/2 becomes 1, negative 1. The 0 becomes a positive 1/2. And the 3/2 becomes a positive 2. So they're changing them in the same manner we had been doing, only they're doing it using the graph. Okay. So the domain still didn't change. Because we didn't change the period, the domain remained the same. And because the range is all real numbers, it's not going to change. The range stays all real numbers. Even though we did shift things around, it's still going to be all real numbers for the range. And the domain is going to remain all real numbers x, such that x is not equal to k pi over 2, and I usually write it this way. I don't write it that way. I write it as half of pi k, where k is an odd integer. So we have those odd multiples of 1/2. Usually when we talk about an odd number, we're talking about the odd integers. But in mathematics, we want to state it precisely. All right. And we'll stop there. Yeah, that to see it goes. So by Saturday, I should have a review for you in files. In Canvas.
You said, like, send a reminder. On that.
Yeah, once I get it up in there, I will do two things. I'll send an email through Canvas and I'll put an announcement.
Just take our test at home, right?
And what about the homework?
The homeworks, this section won't be on there, so that won't be required. By midnight on the day of the exam, the homework for this section, for this test should be complete. So that was up to 6-4. Yeah. And I'll probably put a little bit of 6-5 on there, but not much. If I do, you won't have a B value to worry about. It'll probably be just a cosine. So it's your change. Well, I might throw omega in there. But if it's not on the review, you won't see it on the exam for sure. For sure.
For sure. And then
Andrea, be sure and put your name in chat.
so we are taking our test at home?
Or do you want us coming up here?
Oh, geez. Yeah, I didn't consider that.
Also, how long would we have to do the test?
It will be during the class time.
Oh, okay.
So the exam will be open from 2 o'clock till about 3:45. I usually tack a few minutes on the end. Simply
So each
because,
question's worth roughly 10 points, right?
right, each, unless otherwise specified, each problem will be worth 10 points.
Will there be 10 questions or will it be 10 questions with?
There'll
different
be
parts?
between 15 and 25 questions,
Okay.
depending upon how much material each question covers.
I's
So,
crazy.
what?
I's crazy.
It's
It's the circumference of a circle, right?
2 pi is the circumference of a circle. Tau is the circumference of the circle. Tau can be considered as 2 pi. There's look up
Every
the
civilization-
manifesto of pi. I mean manifesto of tau.
Manifesto. Almost every civilization has contended with that, right? With pi. We got Egyptians, Babylonians, Greeks.
Yeah, well, they had different ways of representing.
Yeah, it wasn't all accurate, right? They were only so close.
This is the Greek letter tau.
I feel like have we used,
No, tau is half pi.
yeah,
I mean, it is no, tau is 2 pi.
So where is the test happening? Here or at home?
Yeah, we need to do it at home. I'll go ahead and do that.
And that's next week, Tuesday.
Yeah, from 2 to whatever, 2 till. I usually tack 15 minutes at the end.
So like 2 to 4, or like 2 to 3:55.
Yeah.
What day
You know-
is the test?
On the day of the test. Yeah. So you come into Zoom and then you go to campus and you have to be on camera. You absolutely have to be on camera. You will get fussed at if you're not on camera, and I will badger you until you get on camera. So, yeah. Because I know cheating happens, but having you on camera tends to cut back on the amount of cheating that happens. I have a whole class of high schoolers who are at a high school through Zoom. And they have a teacher in the classroom, so
You gotta worry about that.
that really helps. Yeah. And
I have a question. Is it all right that if we use notes for the test?
no. When we start doing trig identities, you can use a formula sheet. But you cannot use your notes.
Can I have my unit circle with me?
Well, that's one of the questions on the test.
Oh, is it really?
The unit circle,
So
yeah,
what is the draw?
is to complete the unit circle.
Oh, okay. And I guess no units. Okay.
So that's filling in, I think I put that worksheet in there where you had little. Well, the question will be, you'll have a unit circle. And it'll have the angles marked out.
You have
But
to tell
then
your
it'll,
degrees.
but then it'll have a place for the points. And then a place for degrees
Okay,
and a place for radical, for what do you call it? The radians.
yeah, pi over 2 or
Yeah.
3 pi over 2.
So you start out by filling this in and then fill it in appropriately for the other
Okay,
three quadrants.
alrighty.
Because everything is based on this here.
And once we get that, then we have our unit circle for the test.
Your unit circle.
That's how manifest. It is 2 pi, you're right.
Well, because,
Because we never have been wrong.
yes,
The circle constant.
I am not infallible.
No, sir.
So I'm done with you, unless you have more questions for me.